I'm Brian Jones.
Hey, and I'm Sheila Ferguson.
And we're with the Little Shop of Physics, and today we're going to tell you about another kit that we've created for the Poudre School District. And this one is on
climate and climate change.
And this is a serious topic, but we're going to have some fun sharing it with you today. And we're going to go through 5 different segments. We're going to talk about the different pieces that we have in the kit. And we're going to quickly show you what's in the kit, what concepts it would demonstrate, and how you would use it in your class. We're going to start with the rubber tubing.
Hey, pretty high tech.
Very high tech. And we're going to use this high tech device. It's a piece of latex tubing. We filled it with water. And what the latex tubing does, it provides the stretchiness, and the water provides the mass. And if you stretch out a long length of the tubing, and this isn't really as long as you'd like to go, we'd like to go longer. If I tap it here, you can see there's a wave that goes down the band and back to the other side. So this illustrates the properties of wave motion, and you can use this to illustrate the principles of wavelength and frequency. Frequency is how many times per second am I tapping here. And if I tap at this rate, you can see I'm getting a nice wave going.
Oh yeah.
There we go. Now there's a certain, and the wavelength is the distance between successive high points on this wave. I'm just going to shake it instead. That's going to be easier. And then you can see the wavelength that I get here. If I shake it faster, I end up getting a shorter wavelength. And if I go even faster, even shorter wavelength here. And this is something for your kids to play with, illustrate the properties of wavelength and frequency. Higher frequency, shaking it more quickly, shorter wavelength. That's the distance between the successive peaks of the waves. And after having introduced the concept of waves, now we have to move into the concept of electromagnetic waves like light and radio waves, etc. And the key thing about electromagnetic waves is they're waves of electric and magnetic fields. So to make the concept of the electric field visible,
all right, we're going to use the Fun Fly stick.
It's fun and it's fly.
Right, it is.
Which is why it's called this. So let's see it.
All right, I'm going to press the button, and it's like a little Van de Graaff.
Little Van de Graaff generator.
And I have this thin piece of mylar, and it's very attracted to this right now. But watch for the magic, the science magic.
The science. Oh, look at that. It's starting to pop loose here.
Whoop. Oh, no.
There we go. All right.
Thank you.
So with this one, this is a little bit of aluminized mylar, and it's a little bit of a conductor.
I'm wondering if it's sticking to the table. But there we go.
There we go. And now it's charged up, and you can see it's plumped up into a circular shape. All the different parts of that ring are repelling all the other parts, and it's also repelling the wand. And there's a thing that comes out of the wand. It's called the electric field. And the electric field from the wand repels or makes a force on this little band. And you can see the electric field will go through space. It can exert a force at some distance. And electromagnetic waves are waves of electric fields and also magnetic fields, but they can travel through space and cause that kind of an effect at a distance. And it's a kind of a complex and abstract concept, but we hope that the wands make the concept of electromagnetic waves more straightforward. Now, the electromagnetic wave that people are most familiar with
is light.
And light, we can break it up into a spectrum, and a spectrum is a spectrum of different wavelengths, different frequencies. And so for each student, we've got...
Ooh, a pair of glasses. The teacher gets a whole classroom set.
Oh my gosh, that's fantastic. And what do the glasses do, Sheila?
Well, when you look through them, it's going to break, the glasses are diffraction gratings, and they're going to break light up into, white light up into the different colors. And the rainbow.
Into the rainbow. And the different
Yes.
colors of the rainbow correspond to different wavelengths or different frequencies.
Right.
So as you look at the pattern, white light in the center, you're going to get a rainbow. Blues are close to the center, reds are further out, short wavelengths are far in, long wavelengths are far out. And so you can break the light up into its different frequencies.
I love it.
Waves can carry energy from one place to another, and we saw that with the elastic tubing, but we're going to give everybody a little ultraviolet laser pointer. So Sheila is going to press a button on this, and it's going to give off electromagnetic waves, and in this case, very short wavelength at the very far end of the rainbow. And if I hold this fluorescent tape here, and Sheila shines this on the fluorescent tape, you can't see the wave going from the laser to the tape. But once that wave gets to the tape, it causes it to do something very dramatic indeed. It causes it to fluoresce. And you can see the light that's being given off by the tape is a different color than the light of the laser because it's fluorescence. But something coming from the laser is triggering this effect at a distance. So here's the light from the laser. And you can see it's not very colorful,
No.
not very bright actually. But when it gets here, the energy of the light from the laser produces a dramatic effect in the tape.
No matter how.
Oh my gosh, and what does it do on my shirt? What? So that's kind of cool. The white letters on my shirt are obviously fluorescent.
Yes.
Kind of goes a little bit blue, which is awesome. And so this is just a fun demonstration tool, and we hope that you'll enjoy using this in your classroom. And that's the first piece, is about the nature of waves, and specifically the nature of electromagnetic waves. In the next segment, we're going to talk about a type of electromagnetic wave you might never have thought about before, but is extremely important to the story that we're telling.